what happened. Okay, so while we're waiting for our gas to be made, if you look, we've got two different ways of going about this. We have the battery that didn't work, so we just stuck it into the beaker and we're collecting the gas in the test tubes. And
it's working.
Then we have, here's the option. You guys are really forming a lot of bubbles, so maybe we can see it on the video. You can see that we're doing this the way that doesn't destroy the battery, using some alligator clips. We have nails for electrodes, and you can see that the bubbles of the gas are forming here. This large clip on the battery is a negative end, so it's attached to the red wire, and you can see that the bubble is forming, it's larger than the bubble for the positive terminal. We know the negative terminal is making hydrogen gas. So while we wait for our gas to be made so we can see what happens, see if it really is hydrogen gas being made, we're going to rewrite this procedure. Now, when you guys get to future science classes, you're going to need to be able to write your procedure properly, and we've definitely talked about it lots of times. But when you're given a procedure in a book, it's going to tell you what to do, and then you're going to write down what you did. So you guys just did this. It says fill the beaker with water and dissolve a salt in it. So how would you write that in your lab report to tell what you did? Chris?
The beaker was filled with water and salt was baking soda.
So the beaker was filled with water, or you could say baking soda water. That might be more concise. The beaker was filled with baking soda water. You can do this experiment using like pretty much anything that will conduct. But as you can see, some of us are experiencing some little side reactions that aren't ideal. You can see the brownness there where we've got some corrosion going on. Depending on what you use, you get a different side reaction. And depending on what you want the gas for, you might not want that. So you have to kind of pick your salt carefully. We don't really care, so we just pick the cheapest one. Then number 2 says fill 2 test tubes with salt water and invert them into the beaker so there are no air bubbles. How would you rewrite that to tell me what you did?
The 2 test tubes are filled with water, salt water, into the beaker. Yeah, with baking.
Now, did we do it just the way the procedure says?
No.
No, we didn't wait for the electrodes. We put the electrodes. The nails are the electrodes, by the way. We did that all as one step, so you could probably essentially cross out step 3 and change step 2 to reflect what you actually did. The test tubes were filled with baking soda, water, and then what did we do? Before we put them into the beaker, we did what?
We put the cords into them.
Okay, so we put an electrode attached to an alligator clip into the test tube. And you guys who have the battery underwater, you're not going to do that at all. Then, step 3 is really different than what it says to do, but I mean, we're doing the same thing in kind of a different order. covered the test tube and inverted it into the beaker. You guys will write a whole different procedure, like a battery was put into the baking soda water and test tubes were set over each terminal. So just write what you did so that someone who didn't see you do it could figure out what you did and do it again themselves. The goal of writing what you did is so that somebody could repeat it. So if you actually discover something interesting, it's repeatable by other scientists. Okay, so that kind of covers 2, 3, and 4 to some extent. Darth Vader has joined my class. If you have a cold, the next person who wears those goggles is going to be infected.
No, I don't have a cold.
Colds have about a 3-day incubation period. So if in 3 days you have a cold, the next person to wear those goggles is going to be sick. So, I don't know how long a cold virus can live outside the human body. Anyone? Well, Mrs. Pravat, we need the biology teacher about that one. Okay, so hopefully you've gotten like 2, 3, and 4 from this somehow. I'm not particular about how you write it. Then clip one alligator clip to the negative end of the battery and one to the positive end of the battery. So, let's see. Jenna, how would you do that?
An electrode was inserted in each test tube with an alligator clip extending out of the beaker.
Okay, that's fine. And I kind of covered that here in the wrong step. You can put it in the right step, and that's fine. How would I do, like, step 5? Ava? Okay, so when you say clip, an alligator clip to something, you're using second person, like you do it, like the imperative. Like anyone, maybe you guys are too young, have you ever seen Ella Enchanted? Okay, so second person is a command that Ella would have to obey. So if I say clip an alligator clip to something, she would just have to do it, right? Right, anything you say, like in that, where you would have that you subject implied. Like if you say clip an alligator clip to it, what you're really saying is you clip an alligator clip to it.
You said the alligator clips were clipped to the negative and
Right.
positive.
So when I write a procedure to tell you what to do, I'm going to use that imperative voice. When you tell me what you did, you need to use what's called the subjective voice, which is as if by magic. Clips were attached to the battery as if by magic. So the clips were attached to the battery terminal. And I want everyone right now to look at your data and observations section, make a little drawing of your apparatus, just the way it actually is, not, you guys will have something slightly different than everyone else. And then make a note of which test tube is attached to which terminal, and then which test tube has more gas in it. Hopefully
Draw a picture and
draw a picture. So one would expect that the negative terminal is going to produce more gas than the positive terminal. And so you kind of want to indicate that in your drawing. You guys are actually more visible because of your color change here. So looks like I would expect the one that isn't corroded to be the hydrogen, which is the negative terminal. And it's sort of hard to tell. Oh, it's not clipped in, that's why. Ah! We don't have a good solid connection. Hold on. There we go. That's funny because it's obviously working, but it wasn't like super in there.
It's turning a little yellow too.
Yeah, those nails will have a little extra reaction.
Ours is blue. Ours is just perfect.
Ah, blue. So Dr. Weil explained that, I know, in the chemistry book. I don't know about the physical science book.
Yes.
And what is the explanation of our blueness?
From the acids in the battery.
Awesome. I can't wait to dispose of
You
that
see,
one.
like, the green on the actual terminal.
I know.
See?
Oh, it really is.
That's
Do you know
really
what metal it is that's doing
copper.
it? Because I would assume their nails are iron, and you're getting that rust color from the iron. Yeah, I mean, blue is always a copper sort of indicator, but...
It's like a blue-green kind of.
Yeah.
Huh.
That's what happens with baking soda, right? To copper.
It doesn't seem to be happening to anyone else,
That
so...
was corrosion.
Okay, so hopefully, are you guys producing enough gas here? Give it a little jiggle. As long as you're producing enough gas to tell which one is producing more gas, and one would hope it's the... This is your positive, or this is your negative. No, this is your negative one is the big one. It's this one, and yeah, that one has more gas, so that's good. I'm carrying this camera around like people are going to be nauseated. So, aiming. Oh, I should get a little closer. Okay. So hopefully you've got a little drawing, you've made some observations. I wish it would zoom while I'm talking. Make sure that your observations include that the negative electrode is attached to the one that's making more gas, as long as that is true. So make sure that that's true. The negative electrode should be producing more gas. This will make that yellow a little forever. So the positive is giving us the corrosion. You'll actually redo this experiment in chemistry with lots of extra details. We try to keep it... We might talk about that more, but no. Alright. I'll give you a minute to finish your drawing. And I'm actually going to erase the procedure from the board so we have enough space for other things. So, alright, if we're done drawing mostly, we can flip over to our discussion and see what happens. So, I'm definitely... It needs to run a good long time to collect enough gas. If anybody's getting to the point where, like, your test tube is really full, then we need to pay attention to you. So kind of keep an eye. Some of you are really producing a lot of gas. So let's start over here with Patrick and Joseph. Patrick, the discussion on the back says, water is a the discussion on the back says water is a blank with the chemical formula of blank. So water is and it's in the objective there, so.
Compound?
Water is a compound.
Water is a compound.
It's something. Water is a compound with the chemical formula
Of H2O.
H2O. And the 2, of course, is little to show that there are how many hydrogen atoms? 2 for every how many oxygen atoms? 1. But they don't put the 1. It's not H2O1. We just assume if there's nothing, there's a 1 there. And that's the next question. It consists of 2 hydrogen atoms and 1 oxygen atom.
Why do you have a lot? This is 2 hydrogen blank and blank oxygen.
I'm confused.
Okay. It consists of 2 hydrogen atoms.
Oh, atoms, okay.
I just can't stop reading the words that are on my paper instead of the blanks that are on your paper. And 1 oxygen atom. Which chemically bonds to form, what, Ryan? So water is
2OH.
Well, they were atoms, then when they come together and they're bonded together, now they're molecules. So they chemically bond to form a molecule. So, Max. Hydrogen and oxygen are elements. They're elements. Most atoms exist in nature as individual what, Joshua? Atoms. But hydrogen and oxygen exist in nature as what, Duchesne? Molecules. So they're weird elements. There are 8 of them that exist as molecules, but it's really 2 of the same type of atom bonded together, unlike water that's oxygen with 2 hydrogens, different types of atoms. When they're elements, they're just 2 of the same type of atom bonded together. All right. So, Chris, in this experiment, what was used to break up water?
I don't know if I pronounced this right.
Electricity. We call it electrolysis, but electricity was used to break up water. That's exactly right. And it broke water, down into what? So water is a molecule, and it broke the water molecule down into atoms. Perfect. So in this experiment, electricity was used to break water molecules into atoms. The negative side of the battery produced hydrogen, and the positive side of the battery produced oxygen. Good. So then you want to go back and make sure, we kind of talked about that prematurely, but make sure that you got your hypothesis right and that you thought that you would produce more hydrogen than oxygen. The negative side is producing hydrogen because it's producing more gas, hopefully. So, here's something. Hydrogen is explosive. It'll explode. Oxygen, you saw a few weeks ago that oxygen will relight a splint that's just barely glowing, right? You saw when we had extra oxygen in an environment that splint would just keep lighting back up. However, the oxygen test tube we're not really going to be able to use, number one, because it has the side reactions going on and it gets contaminated. But really, number two, it's hard to actually get the oxygen out of the test tube because oxygen is very soluble in water. So if I put my thumb over that test tube, flip it back over, all that oxygen, it won't come up because it's less dense in the water and then be usable. It'll just dissolve in the water and I can't get to it. That's a bummer. We can't use the oxygen. Hydrogen, however, is not water soluble, and it explodes when exposed to a flame. So we're going to test the gas that we think is hydrogen and see if we hear a pop. So since you ladies had to be the guinea pigs for trying to get the test tubes full, we'll come over here to you two and try that one out. So here, aim this. Now, which one do you think produced hydrogen?
Doesn't rust like oxygen.
Yeah. So what you're going to do, one of you is going to hold the test tube and one of you is going to hold the match. And alright. So Patrick, do you think you can get it out of there with your thumb over it and then flip it over without losing the gas?
Yes.
Okay, this takes a little bit of bravery, to be honest.
Yeah.
Okay, can you do this? I can do it. All right. So
Which one?
this one. So what you want to do is get in there, put your thumb over it, or finger, or whatever, and then flip it over and keep your finger over it. Alright, and then once he gets it lit, yeah. Oh. Let's light a new match so we don't burn Joseph's candle. Okay, now you take the end of that. Now, all you have to do is bring it near, when he says go, flip it straight up like this. Now, as soon as he moves his finger.
Oh my gosh.
Too hot for me.
This is working pretty good.
Yeah, somebody film for me. That's excellent. Alright, so he's going to move his finger and you're going to put it right there before all the gas gets away. Go down low. 1, 2, 3, go. Move. Okay, so hydrogen explodes.
I want to drop it.
Yeah, you can throw it in there or whatever you guys are doing. Okay.
I was gonna burn the paper. They're gonna freak me out.
All right.
I can light.
We're trying not to get the matches wet on the table.
Oh.
Don't do it until it's your time, but you can keep it down there. Oh, here. You put your finger, Ryan.
Playing
So
on
try
that.
to cover.
Oh no, there goes my finger.
Oh, pick it up. Good job.
Live a little longer.
Save the day. I'm going to try to just...
Ready,
Okay.
ready?
Wait. Oh, is that the one? That's not the one. This one. Okay, so you get your finger over this one while I get a new match.
Thank you very much.
Sure.
Okay.
I'll hold it up a little and you get your finger on it.
Alright.
Really twist your
Oh
finger.
no, I'm gonna have to use another match.
Oh, good plan.
I just don't.
Clamp it down, flip it over confidently. Oh, right.
We've gone through 2 now for this one.
Oh, you just let everything out.
Alright, light it, and now you move your finger, and he plunges it in. I'm not sure where that popping.
I think that was the finger.
Nope, we got nothing.
Whoa.
Okay,
So you just gotta up this
Right.
right there.
We made these cool matches.
That's cool. Look at this. Alright. Yeah, you're next. I'll film. You cover. Or you can flip because it's not soluble, and you light. I should get a lighter and do it the easy way. It'll break. They are notoriously breaking.
Put it towards you.
But he's all ready, so. Alright, now you move, he plunges. Awesome.
I broke the match in half.
All of us are breaking the matches, they're weak.
With the batteries.
Matchbox.
Thank you. That's the first time I've ever lived. Yes.
Light while I get my head in. Or
Much easier.
Oh wow.
Yeah. So, are you holding?
So do I get to take this out?
You can, yeah. Even if it means pulling it all apart or whatever.
No, light your hand on fire.
What do you have?
You can't possibly light it. Oh, yeah, you can.
Try this
If you don't have one of this, just let it on the table.
Okay.
He's plugging it. I'm lighting it. Okay, turn it and then plunge. Did you hear it? I heard it.
Yeah, I heard a little pop.
I did. Tiny little pop.
Drop it. Oh, never mind.
There wasn't even a water.
Drop it in the water.
Okay, so which one is yours? This one? Try to knock all of those bubbles off so you get as much gas as you can.
We're doing the hydrogen one.
Great.
Not
Okay,
the orange one,
so
this one.
go ahead and get your thing pulled out and covered and everything.
The negative one. I'll be the one.
This one's not it.
As long as you don't let me drink
Not be touched up in the lab. That's not good. Don't drink out of anything in the lab.
Ooh. I love it.
Smells like cheating. I don't want to lose you. Okay, one of you can put your hand and cover. The other one, I'll get the match.
So we can take out our oxygen one?
Yes, if you can get out, just pull your oxygen one completely out.
Don't even use it?
No.
That one that's corroding?
Yes, the one that's corroding. Okay, plunge quickly.
What?
I think it makes kind of. Oh, that was interesting.
You know, why would you even do that?
And
That was
then,
the oxygen.
yep. And then you plug up.
Make sure you don't.
We're doing it again. We're doing it again. It's still working.
Maybe somebody.
You did it.
All right, anyone ready? What is that? What's that? It's a very disappointing match. Okay.
You need to push it down.
You can even unclip it if you can manage. I couldn't quite. Did you guys get yours out? Do you know which one is your hydrogen and which one is your oxygen?
No.
The follow the negative terminal, the red one. So the one with the red one is the one you choose.
Bend it harder.
So
I don't want to break it. It's over here. Hold this up a little.
Yes,
There it is.
If you
Okay.
can get this out of there.
Wait a second.
Too.
My book?
Without eating it.
My
Yeah,
book.
learn something that
No, it's just an illusion.
It's saliva. I got a car battery in my car.
Okay, I'll light it for you.
Cover one of these guys.
Ready?
But you don't have to do it like, especially you girls with smaller hands, you have to really cover it thoroughly because the gas will leak out any tiny
Can
little.
you like this? I'll light it for her and put it up to it.
Don't try this at home, kid.
Flip confidently and go.
Oh my gosh.
Oh, I saw like a little whoosh.
Alright. She'll light it. I don't know where, I use the match for I use our match for her. Do we have paper towel? Got it.
Okay, you
So what do you do?
confidently flip and then she'll plunge. Alright,
Just flip it over?
plunge, go. Got it.
Didn't make a pop.
That was beautiful.
Don't leave it. Yeah, just it's trying to, but it's not. It's like I don't know, man.
Oh, there we are. Sorry. Okay, that worked.
For
A little tiny work. I don't think I got it on film, but maybe I did.